Venn diagrams are a way of showing different categories. Here's an example of a Venn diagram. Venn diagram shows information about the hair colour of some friends and whether or not they wear glasses. So we can see we have a circle on the left with brown hair, circle on the right wears glasses, and there's an overlap in the middle. First of all, we want to work out how many of the friends wear glasses. To work out how many of the friends wear glasses, I need to look at the size of the set for glasses. Basically, let me get my highlighter. I need to look at how many people are inside this right circle entirely. And I can see there's Bob, Fionn, Dave, and Henry. So I just need to basically count how many of these people there are, and there's just 4 of them. So I can say 4 of the friends wear glasses. For the second part, I want to work out how many of the friends wear glasses but do not have brown hair. So again, it's a specific part of the Venn diagram that I've got to look at. So I want to see how many have glasses but do not have brown hair. So that's going to be Dave and Henry, but I can't include Bob and Fionn because they're also in the brown hair circle, or set, as we should say. So I can say that 2 have glasses but do not have brown hair. How many of the friends do not have brown hair and do not wear glasses? So now I'm interested in the people that are outside of both of the circles. So that's Alice and Isaac. So in fact, that's just 2 people. How many? How many of the people have brown hair or wear glasses or both? This is what we would call the union of the 2 sets, and this is going to be everyone inside the 2 circles somewhere. Some they have brown hair or they wear glasses, or like Bob and Fionn, both. So a lot of the time you'll just see this as how many people have brown hair or wear glasses. We call that the inclusive or, not the exclusive or. And we can see there's 1, 2, 3, 4, 5, 6, 7, 8. Kelly has brown hair and wears glasses, and for some reason she's not already in the Venn diagram. Write her name in the appropriate section of the Venn diagram. Well, if she has brown hair and she wears glasses, she needs to be in the middle of what we would call the intersection of the 2 circles. So I'm going to say, there's Kelly. Here's a question for you to try, and I'd recommend that you copy out the Venn diagram to help you. Please pause the video now and have a go, and when you're ready for the answers, press play. Okay, let's go through the answers. So there were 4 people in the survey that like football and rugby. How many people like football or rugby or both? That's just everyone somewhere in the 2 circles. How many people like just rugby? So that's going to be Ben and Emlyn because they're in the rugby circle but not the football one. What fraction of people like just rugby? Well, there are 2 people that just like rugby, out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 people in total. So it's 2 out of 9. We can also think of this as a probability, the probability that someone chosen at random just likes rugby. Sue does not like football or rugby. Insert her name into the appropriate place in the diagram. Well, she needs to be outside the circles with George. So Sue would be anywhere outside the 2 circles, but still within the diagram. If you're sitting a higher or intermediate exam, this is some terminology that will be useful for you. You don't need this for foundation. So here we have 2 sets. So I've got set A represented by the left circle and set B represented by the right circle. This is some terminology to describe membership in either set A or B or both. We say that the middle or the overlap of the 2 circles is A intersection B, and it's written like this. So it's A, and then there's this sort of I don't know, I guess it's like an upside down U basically. A intersection B. We say A union B, so that A union B, so it's like A and then there's this sort of big U sign, B, that represents everything in set A or set B or both. So basically we cover everything. So if you're anywhere in set A or B, or both of them, you're going to be in the union. Finally, we have this little c. This is called a complement. This represents everything which is not in set A. You might also see this as A with a little dash. A complement, everything not in A. Here's a question using our new set notation. Set F contains the pupils who study French at the school. Set G contains the pupils who study German at the school. The set is represented by the Venn diagram below. Firstly, we want to write down the size of F intersection G, or F intersect G. That's how we would read this. This means all of the pupils who study French and German. So that's going to be here. It's the intersection of the two sets. So the size of the set is 5. So I use this line notation for that. Line F intersect G line. The lines either side just means the size of the set. That's 5. And that means that 5 study both French and German. For B, we want to calculate the size of F union G, that's how we should read that, and state what it means. F union G is all of the people somewhere inside the circles. So that means everyone that studies French or German or both. And we can calculate that. That's 18 plus 5 plus 13, which is 36. So again, the size of F union G equals 36, and what that means is 36 study at least one of French and German. C, write down the size of FC. FC means F complement. That means all of the people who do not study French. So that's going to be the 13 who only study German and the 10 who study neither language. So the size is 13 plus 10, which is 23. And what it means, I haven't asked you what it means, but what it does mean is all of the, how many people are there who do not study French? So that's going to be 23. And that was the size of F complement, wasn't it? For D, we want to write down the size of F complement intersect G complement and state what it means. Now again, that looks really complicated, but if we think about it in terms of language, it is all of those who do not study French and do not study German. So that's going to be people that don't study French and don't study German, so that's got to be the people outside of both of the circles. So I can say the size of F complement intersection G complement equals 10, and I can say 10 do not study French and don't study German. For E, we want the size of F union G complement. Now that again looks quite complicated, but first of all, let's think what F union G is. Well, F union G represents both of the circles and the intersection. So basically, if you're in F union G, you study at least one language. But then we have brackets F union G complement. So that means you're in the set, which is all of the people who are not in F union G, which is going to be everything outside of the two circles, which again is these 10 people here. So I can say the size of F union G, and again it's all complement, is also equal to 10. And that's exactly the same as D. And if you think about it, it's all of the people who neither study French nor German nor both, which is identical to all the people that don't study French and don't study German. It's the way language works, and in fact, this is something called one of De Morgan's laws, a mathematician De Morgan. Here's a question for you to try. It has 3 Venn diagrams, but it's not any more complicated. You're unlikely to get something this difficult in the exam, but it's a good exercise, especially if you want to take statistics a bit further. So pause the video now and have a go, and when you're ready for the answers, press play. Here are the answers. Firstly, A intersect B intersect C. That's everyone who is in A and B and C, which is going to be this, so that's 3. The size of A union B union C, that's everyone who is in A or B or both. Sorry, A or B or C or both. A or B or C or all three of them. So that's everyone inside the circles. So we just need to count. We have 10 plus 1 plus 5 plus 2 plus 3 plus 3 plus 5, which is 29. Let me do that again. 10 plus 1 plus 5, 2 plus 3 plus 3 plus 5, which is 29. A complement, that's everyone that is not in the A circle. So basically everyone who is outside of A. So let's count them up. We have 5 plus 3 plus 5. So that's the people in B and C, but not A. Oh, sorry, that's the people in B or C, or both, but not A. And then 6 on the outside, so that's 19. And then lastly, A union B union C complement. So that's basically everyone who is not in the circles somewhere. So they are not in at least one of A, B, and C. So that means they've got to be on the outside here. So there's 6 of them.